beginning, and today is March 1st. So 2.8 is basically three different titles, three different things involved here. The first one is the distance formula. The second one is the midpoint formula. And the last one is the equation of a circle. Yes, please.
When you say equation of a circle.
Yes, we're going to get there.
Okay.
Bear with me for another 10 minutes. So we already know now the distance formula, which is the square root of x2 minus x1, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if you give me two ordered pairs, any two ordered pairs, we will determine the distance. But before that, I just want to say one more thing, that if we have those 2 points, A and B, and the distance between A and B, the measure of the line segment, AB, somewhere right in the middle, where the two pieces are equal, we say M bisects, divides into two equal parts, the line segment AB. This is what we call the midpoint. And we can show with right triangles, like we did with the distance formula, that the coordinates of the midpoint are the average of the coordinates of A and B. Average meanings, because there are two.
Plus each other divided by 2.
Thank you very much. And the same thing, y sub 1 plus y sub 2 divided by 2. So now please feel free, so that's the midpoint formula. Feel free to give me two ordered pairs that you can think of, or we can pick them from the book. Doesn't matter. So we can determine the distance and determine the midpoint. And I would like some negatives in there too. Anyone?
4, negative 4.
4, negative 4, awesome.
Negative 12, 2.
Perfect, awesome. So therefore, I will consider this to be x1, y1, and this to be x2, y2. Agreed? Perfect. So this is what I recommend, and I accept other methods as well. So I normally copy the equation again. I'm going to stop, however, and ask a quick question. So what type of number will this be? What type of number will this be?
Positive.
Right, because it's squared. So no matter what I have in here, once it's squared, I'm done, right? Perfect. What type of number will this be? And then when I add a positive to a positive, right, will I ever see the distance equals the square root of negative 47?
No.
Awesome. Good. So my next step is I write underneath each and every one of them, meaning I copy my x2 here as negative 12. I copy my x1 here as positive 4. I copy my y2 here as 2. And I copy my y1 here as negative 4. I didn't replace them. I just copied them underneath. And now let's think together. Negative 12 minus 4. Negative 12 minus 4.
Negative 16.
Negative 16 squared.
Which is 256.
Yes. Plus 2 minus negative 4. 6 squared.
36.
That's it. This is what I want to see. Why? Because you may be tempted or may forget and write a negative number. So this is what I recommend. So then D equals the square root of,
292.
if I'm asked to give an approximation, I will punch it in the calculator and give an approximation. If I'm asked to give an exact answer, then I would try to simplify this. So 292 obviously is an even number, so it must be divisible by 2. So then I have 1 and 9 and 6. When I divide 292 by 2, 2 divided by 2, 9. Oh, I'm sorry. This is 4. I'm not sure where I was thinking, what I was thinking. Sorry about that. So 2 divided by 2 is 1. 9 divided by 2 is 4. And I have 1 left over, and 12 is 6. Good. It's still an even number. Okay. Divided by 2 again.
73.
73. And now I have to stop. So since 292 is 4 multiplied by 73, when I take the square root, I will write the square root of 4, which is 2, times the square root of 73. Depending on how the answer, especially my math lab, how the answer should be presented. So now let's also determine the midpoint for the same 2 points that he gave me. So I have to add the x values, the x coordinates. Please add the x coordinates. Negative a divided by 2. Very good. Let's add the y coordinates. Negative 2 divided by 2. Negative 1. So we determined that the distance between the points you picked is actually 2 the square root of 73. Or if I approximate, I don't know where my calculator is. Here it is. The square root of 292 is 17.088. If they're asking us to determine an approximate distance, then it's going to be depending on how many decimals they want and so on and so forth. Any questions for me? Good. So the last thing we have to look at is the equation of a circle. Ready? And then we move on to chapter 3, which the first section should be entire review. I will not consider it a review. I will do everything from scratch with you. Okay. I know this is not a circle.
Not perfectly, but
It's
close
not a
enough.
perfect circle, but bear with me and say it's a circle. Obviously, a circle has to have a center. We like the notation for the center h comma k. So see, h is the x coordinate, k is the y coordinate. This is the center of the circle. Of course, there is a radius. And the radius connects the center to any point on the circle. It can be this point. It can be this point. It doesn't matter. The distance will be the same. Yes, the distance between the center and any point on the circle will always be the same, right? The distance for it. Okay. Good. So I'm going to call this point A. And the coordinates of A must verify the equation of the circle, which we don't have yet. So A has generic coordinates, x comma y. Here's a question for you. I claim that the distance AC is the same with the radius. Would you agree with that?
Yeah.
Yes. The distance between A and C, the way I presented it on the graph of the circle, obviously must be or must equal the length of the radius. Agreed? Good. So I'm going to leave R right here on this side. But on this side, I want you to dictate what I could write as the distance, AC.
You have to go back to the distance formula.
Correct. So then I have to copy the square root. Then I will have to have something squared plus something else squared. Yes, awesome. But we prefer to go it the other way around. But you're right. It's not going to make any difference. But we prefer x first and then the number second. Awesome. So Brian, can you say it again? X minus h, everything squared.
Y minus k.
Everything squared. Now, this is the equation of the circle, but we prefer it without the square root. If I prefer this without a square root, what should I do to both sides? Exactly. So I will square the left-hand side, and I will square the right-hand side. What would you tell me to write on the left? X minus h squared plus y minus k squared equals, that's it. This is the equation of a circle with center, what? Awesome. And radius,
R.
awesome. There are three types of problems here concerning the equation of the circle. Three different types. The first two are much easier than the last one. So let's start with the first one. First type of problem. Given, and you're going to give me a center and the radius, whatever you want.
0, 0.
Okay. It's a good one. It's a very good one. But I'm going to ask for one more after this. And the radius,
1.
very good. It's the simplest possible circle that anyone can think of. Awesome. Good pick. And I'll let you know next time if my other students will pick the same thing. Good. So given the center and the radius, write the equation of the circle. I'm ready. Other than Tom.
1 minus 0. Squared. You need to find the
So what do I write here?
can the point not be 1, 1?
But you said to me that the center is 0, 0. So what will this become?
0.
So remember, this is the h and the k, not the x and y. Okay, I'm ready.
X minus 0 squared.
Which is? Perfect. Plus.
Y squared.
Perfect.
R squared.
Which is?
R squared.
Which is?
1.
That's it. This is the equation of this circle with the center at 0, 0 and the radius of 1. Make up another one, please. And I want some negatives in there as well. Negative?
1.
Yes?
2.
2. Awesome. So this is a second example. Not the second type. It's still type 1. And give me a radius.
17.
Okay. Perfect. I want the equation of the circle, please.
X plus 1
Awesome.
squared.
Yes.
Y minus 1 squared equals 17.
That's it. This is the equation of the circle with the center at -1, 2 and a radius of 17.
Best you can do is just, actually, you might want to just keep it as is, right?
Yes, or you can write 289.
Yeah.
Yeah, you can. Good. Do we understand type 1? We're given the center and the radius and we write the equation of the circle. Yes? Okay, type 2. We are given the equation of the circle. Let's say now they're asking us to find the center and the radius and graph it. also. Other than Tom, can anyone give us the center of this circle? Very good. Do we all understand y is 4, -3?
I do.
It's okay if you say no. Don't be shy. Is this okay? Bless you. What about the radius, please? 2. Awesome. So the center is indeed 4, -3, and the center is 2. Here's how I graph the circle. I must start with the center. 1, 2, 3, 4, 1, 2, 3, right here. And please, I know you understand this, but so here's the center. I know the radius is of length 2. I will create a point on the west, a point 2 units away east, a point 2 units away north, and a point 2 units away south, and then connect them. Ready? Up 2, left 2, right 2, down 2. Here's my circle. So this is the equation of the circle, or the circle with the center at 4, -3 with a radius of 2. Any questions on type 2? Now type 3 I cannot make up. We have to choose from the book. Because they have to work, and it will take me a while to come up with something that I will have to multiply a few things. Okay, on page 332, any problem you would like from 53 through 64?
Yeah, 59.
Okay, but I would prefer to pick an even number because you can do the odd numbers and check the answer. 58?
Yeah.
58. X squared plus y squared plus 12x minus 6y minus 4 equals 0.
What's this have to do with the circle, huh?
Good point. Good point. That was you're reading my thoughts before I even formed them. That's unfair. You know that. Okay, so that's exactly what I was going to say. I was going to ask you, what does this have to do with the equation of a circle? Here's the question, first of all. We haven't read the question yet. The question is saying this. An equation is given. Check if this is the equation of a circle. Well, I don't know if it's the equation of a circle or not, but I do know that the equation of a circle is this. So what do you think, other than Tom, what do you think we have to do with all this, if possible, in order to identify whether it's like this? Because if I can work on this with algebraic manipulations and make it into this, then I'll say, yeah, it's a circle. I cannot add or subtract stuff without accounting what I'm doing, right? So what should I do to such an equation to make it look like this? Say it again. Okay, we can start with that. But what is the idea? What am I trying to do? Close. Close.
See if it is a circular equation.
No. AJ?
Do the grouping thing?
Yes, it's called what?
Is that called grouping? Or,
Close.
okay, sorry, I forgot the term.
Factor by group.
It's a method that we used in solving quadratic equations, and I
Wait, in
said,
the square? It's an elimination game, right? They had all the others covered.
and I made the deal with him. He's on gag order. Yes, indeed. That is the idea. But AJ helped you this time.
True, true.
Okay, so all I have to do is manipulate all this and change it into two what?
Two
Com-
things.
Completed,
Complete squares.
yes. One that has only x and some number, and the other one that has only
Y.
y and some number. Exactly. So, okay, he's falling asleep. Let's do something quickly now. That's our chance. Okay, so I'm looking at x squared plus 12x. What is the procedure? What is the first step?
Take X out.
For completing the square, first step.
Find B.
Yes, which is in this case?
12.
Awesome. Then what do I do with b? What? Yes, 6. What do I do with 6?
Square it.
Right, and what do I do now?
Add it to both sides.
Exactly. Thank you. Perfect. So now 1, 2, 3 terms are here. Tell me what to write. Other than Tom.
I do need to
Feel
learn.
exhausted. It's like a race against you.
Factor out
Say it again, Eddie.
factor
Yes,
everything with X.
yes, but we already know the answer. We are way beyond factoring. It's done. These 3 make up what?
Quadratic.
X plus x squared, or x plus x squared.
Very good. That's what we did. That's why we learned that complete the square. For this, not for solving quadratic equations.
Then you have to do the same for Y.
Awesome. So then, I'm looking at y. I have the y squared. I have the negative 6. Y. So,
Squared. Add 9 to both sides.
okay. So I'm going to add 9 to both sides. Now this and this and this are where?
Let's see.
No,
Huh?
we don't. You don't.
Okay. Y minus 3 squared
Yes, but I need a symbol. Awesome.
plus.
Yes, perfect. So then y minus 3 everything squared. Great. Excellent. And also, Brandon is right and Brian is right. He said from the beginning, get rid of this 4. Yes, that's fine. So now I have this and this and this. What is left on the other side?
41 squared. Or 45. No, not 49.
Thank you. Now here's the final question. I shouldn't say final, one question. Does this represent a circle?
Yes.
Of course, it does. So all we did was to complete 2 squares, and we changed all this into this. Do you think that if you square this and add them up, will you get 49? I mean, will you get the same, not 49, but you know what I mean? You will get the same equation from before? Absolutely. Because we added to both sides. So nothing changed. The only thing that changed was the presentation. The equation looks different, but it's the same one. Good. So we had to bring it to this form so we can identify the center and the radius. Can anyone give us the radius? Not Tom, though.
Same.
Okay.
7.
The radius is 7. Good. And the center? Very good. Awesome. And yes, we can graph it if you want. We plot negative 6, 3, and then we go 7 up, 7 to your left, 7 to your right, 7 down, connect those 4 points, and create the circle. I think we need another one like this, correct? Is that a yes? Is that a no? Yes? Good. So let's choose another. Let's say 54. In 54, we have x squared plus y squared plus 8x plus 4y. And then plus 16 equals 0.
Can we do one of
Say it again.
Squared.
Say it again.
We do one that has a number in front of the x squared.
Very good point. That will not be a circle. Very good point. If there is a number in there, it's not going to be a circle. It could be a hyperbola or a parabola.
What about one with a higher degree? Say you have 3 or 4, then it's not a
It's not
circle.
a circle. Nope. Nope. Good point. Good. So let's work on this. 1 minute. Think about it for 1 minute and we'll do it together, please. Can anyone tell us what to add for complete the square in X?
He said it.
16.
Awesome. If you look carefully here, please. It's there. There's no need to add it and to both sides.
So then you just factor it.
This will be
X plus 4 squared.
take a moment and tell me what we have to add to both sides for complete. Yes,
For y, you just gotta add 4.
thank you.
You
So
mean
then-
y plus 2 squared.
Equals
16. Right? Or 4
What?
squared. 0? Can't be.
4.
Oh, you don't square.
Is this the equation of a circle?
Yep.
Can anyone give us the center
-4, -2.
and the radius? Very good. Any questions? Yes, please. Brandon?
So if the number is already there, then we shouldn't be adding it to that.
Yeah, it was not going to make a.
'Cause I got 36 and then 6.
So you didn't get the same answer.
Well, I got like the same like center, but not the same radius.
Okay, so you want us to add 16 to both sides.
Well, like it,
Okay,
yeah.
let's do it. Let's do it. Because we may not notice, right? In a test situation, the anxiety may not, right? May not make us think that there is a 16 in there, so we want to add to both sides. Awesome. So let's do that. So we have x squared plus y squared plus 8x plus 4y plus 16 equals 0, correct? So we know we have to add 16 to both sides. Let's say I haven't noticed this. I didn't see it. So I'm going to add 16 to both sides. So then this and this and this, they're all positive, right? So x plus 4, everything squared, plus, let me use a different color. For this and for this, I have to add 4 to both sides, correct? Okay, so now this and this and this will be y plus 2 squared, correct? And now I have this that I have not used, this that I have not used, and this that I have not used,
Okay, yeah, that's what I did wrong.
right? Even if you say 16 plus 4 is 20, but you have to bring 16, which has a negative sign. So 20 minus 16 is still 4. Very good question. Thank you. Okay, very good. Anything else? This completes chapter 2. So let me find I found it. Okay, here it is. So all this is completed. And I'm hoping that you are going to redo the problems we did in class. then do all these problems, or as many as you can. As many as you can, check the answer in the back. Okay? So now we are going to start section 3.1, chapter Polynomial and Rational Functions. So this is a complete review. I'm hoping to be able to finish it today, hopefully. I still need to go to word problems and so on and so forth. But this should have absolutely no secrets because this was entirely covered in the previous course. Okay? But I will not consider that. I will start from scratch. Let me see where I'm with time. 30 minutes? Okay, I'm fine. Good. So chapter 3. It has another long title, Polynomial Functions and Rational Functions. Polynomial and rational. Polynomial and rational functions. The simplest polynomial function we know is,
X squared.
that's quadratic. The simple polynomial function is x, right, which is linear. The next one will be x squared, which is quadratic. These are the simplest possible, linear and quadratic.
And cubic and quartic.
Exactly. We're going to get to that. So in 3.1, so we're not going to talk about linear again. We already did extensively. So we're moving on directly to quadratic. We did use quadratic a lot in transformations. We know that this is x squared, right? It has a positive leading coefficient and it opens upward. And this will be negative x squared, flipped over the x-axis, correct? Okay. So 3.1 deals with quadratic functions. A quadratic function can be given to us in two different ways. Here's the first way. Ax squared plus bx plus c. And it can be given to us in a different way like this. Yes, we know h, we like h and k, but they're not the same. This h and this k don't come from the circle. It just happens we like to use the same notation. Okay, can anyone again, let me just re-emphasize that A, B, and C are real numbers. But A, I claim, cannot be 0. Can anyone explain, other than Tom, why A cannot be 0? B and C can be 0, but A cannot be 0. What happens if this little a is 0? It makes it not quadratic. Exactly. That's what happens. It collapses into a linear equation. Correct. Very good. Now, can anyone tell us what is the difference between this form and this form? Look at them carefully. We just talked about this idea 5 minutes ago. What is the difference between these two?
H and the K.
Nope. Between this form and this form. We just talked about this procedure 5 minutes ago. What is the procedure called? Exactly. So this one does not have the square completed, but this one does. So it's not such a big deal. It looks more, I don't know, sophisticated than this one, but it's the same thing. So if you give me any quadratic function, I can complete the square and make it like this. If you give this to me, I can expand it and give you that back. Right? So let's start with this one. Graph it, go through all the steps necessary to graph a quadratic function, and then we're gonna look at that one. Okay? So give me an example, or let me this time pick one example myself. Negative x squared minus 6x and minus 8. First step, the shape. So what is the question here? Graph.
Quadratic.
Graph f of x, indeed, it's quadratic. What is the shape? By the shape, we mean, does it open upwards or does it open downward? In other words, does it have a minimum or does it have a maximum? And let's just think in terms of negative x squared. Remember when we graphed x squared, it looked like this. How will I graph negative x squared? Right. Right. So does it have a maximum or a minimum? Yes. If the leading coefficient, in this case, is -1, the parabola will have a maximum. If the leading coefficient is positive, then the parabola will have a minimum. So this is a maximum, and this will be a minimum.
Question.
Please.
What if it's a negative less than 1? Like, say, -2?
It doesn't matter. Still has a maximum.
I see.
Yep. Very good. So this point that here is called maximum and here is called minimum, both of them I should say, they are called vertex. So this is a vertex which is a maximum, and this is a vertex which is a minimum. Plural vertices. Okay, step number 2. Let's find the vertex. Anyone remembers how to find the x-coordinate of the vertex? It's okay. So let me tell you or show you how you remember this very easily. We do have to know the quadratic formula, right? So ax squared plus bx plus c equals 0. If the equation is in this form, then I can use the quadratic formula. Can anyone other than Tom give us the quadratic formula?
It actually reminds me of the time I forgot part of it during the last test.
It's okay.
Negative b plus or minus square root of a squared minus 4ac over 2x.
Thank you, Eddie. Very good. So why did I put this here? Only for one reason. To easily help you remember the x-coordinate of the vertex. Here's the x-coordinate of the vertex. This part of the quadratic formula is the x-coordinate of the vertex.
That's called something. The argument? No.
Yes, it is the argument because it's the x value. Yeah,
Right.
if you want to call it that, that's good. Very good. So let's identify it. Negative outside. What is b in our function? Not Tom.
-6.
Very good. Divided by 2 times a.
My head actually hurts. -2.
Perfect. I see 1, 2, 3 negatives. The answer will be
Negative
awesome. 6 divided by 2.
3.
Very good. So we found the x-coordinate of the vertex. The vertex, which is the point that will give us the maximum. Okay, how do I find the y-coordinate?
The other part, right?
No.
Hmm.
So I have a function, and I have the x value. What is the only way to determine the y value?
I don't plug x in the equation.
Thank you. This is f of -3. Very good. So f of -3 is -3 squared minus 6 times -3 minus 8. Which operation needs to be performed first?
Squaring.
Awesome. How much is -3 squared?
9.
With minus in front.
-9.
Very good. Awesome.
Plus 18 minus 8.
Add these two for...
Plus 10.
Yes? No. Do this first. -17 plus 18.
Well, still 1.
Correct. So the coordinates of the vertex are -3, 1. Very good. Step number 3.
Plug it in.
We already did.
I mean the point, the ordered pair.
No, we already did. That's all we needed to find the vertex. Now I want the x-intercepts. And I'm going to put a comma, and I'm going to say if they exist. What does that mean?
If,
So-
if it's a real number, be it a decimal or a fraction or something under a radical, but if it's any of those, sure, but say it's, you know, the root of a negative number.
Okay, no, that's not what we are talking about. That's okay, that's okay. No, never. Okay, so a maximum has 3 possibilities. By the time I finish graphing them, he's going to give us the answer. You'll see. Okay, so a maximum can do this. A maximum can do this. And the maximum can do this.
It can be 2, 1, or none.
Correct. As I said, by the time I finish, I won't be able to ask any question. So how many solutions, if this is the case, how many solutions or x-intercepts will this function have? Exactly, correct. None. None. How many here? Distinct. Very good. 2 distinct solutions. And here, still 2, but not distinct. They are the same.
1 real solution.
1 real solution, 2 real solutions, or imaginary in this case. So now let's look at the vertex. Where is this vertex? 1x is -3, but where is it? Is it this case? Is this, give 1 second. I know you have the answer already. So is it this case? Is it this case? Or is it this case? By simply looking at the vertex, I want to identify which case it is, because if there are no solutions, I don't want to waste my time. It will take me 3 minutes, 4 minutes, who knows, to find the solutions. But if they don't exist, at least I move on to the next step without wasting my time. How do I know which case it is? By simply looking at the vertex. Is it case 1, case 2, or case 3?
Is 2 x-intercepts.
Correct. How do I know?
Because the
Y coordinate.
yeah, the y coordinate of the vertex is greater than 0.
Exactly. Here the y coordinate will be 0. Here the y coordinate of the vertex must be positive. And here the y coordinate of the vertex will definitely be
Negative.
under the x-axis, negative. So we do know that they exist. And furthermore, we know that there are 2 distinct solutions. How do I find them now? How do I find the x-intercepts for any function on the planet, including this one? Set?
Y to 0.
Excellent. So I have to set y equal to 0, which is -x squared minus 6x minus 8 equals 0. How would you address this equation, and what is it? Never. Never. There are 4 methods. But first of all, it's not ready for anything. It's not cleaned up. How will I clean this up?
Change the signs.
Multiply both sides by -1, of course. Very good. So multiplying both sides by -1 will give us,
X squared.
very good,
Plus 8.
very good, awesome. And now let's think. Never complete the square. So there are 3 methods left. Which one? If I remember, yes, not by grouping, but factor. So because we don't have 4 terms. But remember what we said. If factoring takes this long, do it. Otherwise, quadratic formula in this case. But factoring takes that long, as I chose it to be like that.
X plus 4, x plus 2.
So the 2 options are,
-4, -2.
So the x-intercepts are
Once again, -4, -2. -4, 0. -2, 0.
perfect. Step number 4, the y-intercept. This will always exist, so I will not put a comma and say if. Good, how do I determine the y-intercept for any function?
Plug in X.
Yeah.
I plug in x, what?
X equals 0.
Yes, so I have to find f of 0. That's not a big deal. How much is f of 0?
-8.
-8. Thank you. What is the ordered pair?
0, -8.
Perfect. 5, 6, and 7. I want to jump to 7 and I'll come back to the other 2. I want the range. And you could say, wait a minute, I haven't even graphed it yet. Yes, but we know the range. Can anyone give us the range other than Tom? Does this function have a max or a min?
Max.
Max. What is the max value?
-8.
Remember the vertex. What are the coordinates of the vertex?
1.
Yes, the maximum value of this function is 1. That's where the vertex is. That's why we know it's -3, 1. Good. So what is the range then?
-infinity to 1.
We established, perfect. We established that this is the case, right? So from -infinity to the maximum value, which is 1. That must be the range. Good. Last item, which is number 5, is the axis of symmetry. So we're not talking about odd and even functions. We are talking about a vertical line going through the vertex that is the axis of symmetry of a parabola. Going through, so this is the vertical line, the axis of symmetry of the parabola. This piece, if my graph were perfect, which is not, this piece would have been a mirror image of this piece with respect to the axis of symmetry. Same thing here. Yes, but it has to be x equals. Yes, very good. Now we are ready with all this information. We are ready to graph the function. We start with the vertex. What is the vertex again?
-3, 1.
We continue with the axis of symmetry, which is not part of the graph. So it's not going to be a solid line. So this is x equals -3. This line will only help me keep the graph in shape. X-intercepts.
-4, -2.
Notice that I would have had a mistake here if these two were not symmetric. If this were, for example, at -1 and this one at -4, I would have said, whoops, something is wrong. And then I have to plot the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. I have to keep the graph in shape as much as possible and not too acute at the vertex. I always write the name or the equation I graphed. I graphed f of x, which is -x squared minus 6x minus 8. This is the way I recommend we graph the function, going through those steps. And I will stop, but I would like to work on a word problem. So you see how important the quadratic function is. Okay, 58. Any questions for me?